Welcome to the Explainer. Let's jump right in. Today, we're taking a deep dive into the hidden bedrock of global commerce. I'm talking about the systems that quietly power everything: financial transactions, healthcare portals, telecommunications, you name it. We're looking at enterprise Linux automation, and specifically how modern organizations actually govern their massive infrastructure fleets. If you've ever wondered how the digital world stays online, secure, and compliant 24/7 without completely collapsing, well, you are absolutely in the right place.
So here's a question for you. How do you manage 10,000 servers without losing your mind? It sounds kind of like a setup for a bad IT joke, right? But for enterprise teams, this is a daily reality. The sheer scale and complexity of modern infrastructure, we're talking on-premises data centers, public clouds, edge computing nodes. It makes traditional, manual administration literally, mathematically impossible. Think about it. If it takes a human, say, 10 minutes to log in, apply a single security patch, and verify it on just one server, doing that across 10,000 servers would take nearly 70 days of non-stop work. And by the time you're done, you'd already be months behind the next security threat. That's wild.
The answer requires a massive paradigm shift. It's this: you don't manage the servers. You manage the fleet. We absolutely have to transition away from this reactive, machine-by-machine maintenance and move toward a proactive, policy-driven model. Basically, you have to stop treating each Linux machine like a unique pet that needs individual attention and start treating them as part of a highly coordinated, unified fleet.
Section 1. Desktop versus Enterprise Linux.
To really grasp this shift, let's zoom in on the smallest unit of our infrastructure. When a lot of folks hear the word Linux, they instantly picture some hacker typing in green text, or maybe a tech enthusiast customizing their personal desktop with all the latest updates and flashy new tools. But enterprise Linux? It is a completely different beast. It prioritizes absolute stability, advanced security, long-term support cycles, and unwavering business continuity. An enterprise distribution isn't about experimenting with the latest shiny software. Not at all. It's about providing a rock-solid foundation that a massive bank or a hospital can rely on for years, literally years, without a single unexpected disruption.
Section 2. The Manual Management Trap.
So what exactly happens when you try to scale that super stable foundation using outdated manual methods? Well, you fall straight into the manual management trap. And that leads us to a really critical concept: configuration drift. This is what happens when systems that started out completely 100% identical just gradually diverge over time. Why? Well, because of manual administration. An admin makes a quick emergency fix at 2 a.m., or maybe a local user tweaks a setting, or an update accidentally gets applied to server A but not server B. This manual variability is actually the primary source of security gaps and compliance failures in large organizations.
And this reality of drift, it breaks down those identical systems across so many different layers. It happens at the package level, where suddenly your servers are running totally inconsistent software versions. It happens in core configuration files like SSH. It breaks your security baselines, meaning your firewalls end up with completely different rules. It even causes kernel and operational behavior drift. That's when two theoretically identical servers behave completely differently when you put them under a heavy workload. So suddenly, you don't have a standardized fleet anymore. You have thousands of unpredictable, highly vulnerable individual machines. Yikes.
Because of all this drift, you are left with a terrifying vulnerability exposure window. In a manual environment, a bad actor can target a newly disclosed vulnerability within hours. But human-driven workflows, they require days for manual approval and then weeks for patch scheduling because of various bottlenecks. So the actual remediation gets severely delayed. And that gap, that time between disclosure and fix, is exactly where data breaches happen. Relying on human intervention across a sprawling environment is quite literally a race you cannot win.
Section 3. The power of automation.
So how on earth do we close that window and fix this configuration drift? We use a magic weapon. You gotta ask yourself, are you trying to play every single instrument yourself, or are you conducting the orchestra? Enterprise automation shifts IT from frantically running around trying to put out fires to standing calmly at the podium and enforcing policy. Instead of logging into servers individually, you define the rules, and the automation layer ensures every single machine plays exactly in time, right on pitch.
Here's what conducting that orchestra looks like in practice, specifically with an automated patch workflow. Instead of taking weeks, the system centrally orchestrates the whole thing. First, it automatically identifies the applicable updates. Second, it prioritizes them by risk severity. Third, it applies them across your system groups in parallel during controlled windows.
And finally, it verifies the deployment through automated checks. It elegantly rolls out massive security updates without disrupting any production workloads. No more missed patches, no more asynchronous, messy patch states.
But here's the best part. Automation goes beyond just patching. It actually gives you a self-healing infrastructure. This is incredible. If someone logs in and manually changes a configuration, like maybe they temporarily relax a security policy or downgrade a package for testing and forget about it, the automation detects that deviation and instantly self-corrects. It automatically reverts the system right back to the approved baseline, without waiting for a human administrator to even notice. It's literally continuous compliance enforcement happening in real time.
Section 4. Mastering the Linux Fleet.
Now that we have this magic weapon, let's zoom out to the big data center view. To truly master the fleet, you need something called desired state configuration. This right here is the ultimate antidote to configuration drift. Instead of treating configuration as a one-and-done deployment task, you define a central, structured model, the desired state, of exactly how a system must look and behave. We're talking what packages are installed, what firewall rules are active, what kernel parameters are set. The automation system then continuously evaluates your live servers against this desired state, enforcing true lifecycle governance.
So what tools do enterprises actually use to pull this off? An enterprise-grade foundation, like SUSE Linux Enterprise Server, paired with SUSE Manager, provides exactly these critical capabilities. You get centralized orchestration, policy-driven automation, and unified compliance dashboards, so you can easily prove to auditors that your systems are locked down. But what's especially cool here is live patching. This is the ability to apply critical security updates directly to the running kernel without requiring a reboot. That is an absolute game changer for minimizing operational downtime.
And it all culminates in one single control plane. SUSE Manager essentially consolidates all of your patching, all of your configuration drift control, and all of your compliance tracking into one unified view. You completely eliminate that messy fragmentation of using 5 different tools to manage your infrastructure.
Section 5. Scaling the hybrid cloud. For our last step, we are doing a massive zoom out to a truly global scale. Today, Linux is no longer just an operating system. It really functions as the unifying infrastructure layer for everything. I'm talking cloud-native Kubernetes clusters, private data centers, distributed edge computing nodes sitting in a retail store or a smart factory, you name it. It provides a completely standardized abstraction layer. And this is absolutely vital because it prevents vendor lock-in, giving you a portable, flexible execution environment literally anywhere in the world.
This really bridges the gap between the IT basement and the boardroom, because we aren't just doing this because the tech is cool. A deeply technical feature like kernel-level isolation that directly translates to the tangible business value of risk reduction and compliance. Native Kubernetes integration is what actually enables rapid business innovation. A standardized Linux stack drives massive structural cost efficiency, mainly because you aren't paying for duplicate tools and training across different platforms. And uniform scalability directly powers real business agility. This isn't just an IT upgrade, it's a structural business transformation.
And that leaves us with one final thought to ponder. Think about your own organization's setup right now. Is your infrastructure actually ready to scale automatically, enforcing security and compliance on the fly? Or are you still out there, manually managing the chaos, one server at a time? It's a critical question for the future of any digital business. Thank you so much for joining me on this explainer. Until next time, keep learning and stay curious.